Assalamualaikum and hi everyone! Today, our group will explain about centrifugal pump. In this video, it will contain introduction, the components of pump, the principal operational of pump, the application of pump, and lastly, the advantages and disadvantages of pump.
I can tell you want me.
Okay, now, what is centrifugal pump? Centrifugal pump is a machine which is rotodynamic pump that uses a rotating impeller to increase the velocity of a fluid and also widely employed for liquid transfer in piping systems. In the centrifugal pump, the fluid will enter the impeller near the axis, gets accelerated and flows upward into a diffuser or volute chamber. The discharge characteristics are effective for large discharge at lower heads in a variety of applications. Next, I will talk about the component of centrifugal pump. This pump has two components, which is impeller and volute-shaped housing. For impeller, there are three types, which is closed impeller, semi-open impeller, and open impeller. The closed impeller feature vanes sandwiched between two solid, circular plates, ensuring efficient liquid flow from the eye to the discharge port. Ideal for clear liquids, this is the most common type of impeller in this pump. Next, semi-open impeller featuring vanes attached to a single plate and exposing one side to the pump housing. It prioritizes tolerance for suspended particles and versatility with viscous fluids. Despite lower efficiency compared to closed impellers, their design allows immediate interaction with the liquid in the pump casing. Lastly, open impeller featuring vanes open on both sides prioritize handling suspended solids but are weaker due to lack of support. These pumps are smaller and less powerful to reduce the risk of breaking vanes. The open design results in liquid interaction within the casing, making open impeller centrifugal pumps the least efficient option. Next component is volute-shaped housing, which is the casing that encloses the impeller. The function of volute is the liquid velocity will convert to pressure as the impeller discharges fluid through the casing nozzle. The mechanism achieved through a gradually increasing cross-sectional area in the volute, enhancing fluid flow through area and elevating static pressure. Next, the off-center impeller rotation increases liquid velocity in the casing, initiating fluid flow. The pressure generates starting with the smallest cross-sectional area near the impeller. Fluid gains pressure as it traverses the volute to the discharge area with the largest cross-sectional area. And for the optimal pressure, maximum pressure is attained at the discharge area corresponding to the greatest cross-sectional area in the volute. That's all from me. Now I will pass to the next person that in charge for explain the operational principle of this pump.
I hope you guys are still with us because right now I will continue to the operational principle of centrifugal pump. As we know, the pump consists of two main parts, which is the pump and the motor. To begin with, the motor is an electrical induction motor which allows it to convert electrical energy to mechanical energy. This mechanical energy is used to drive the pump and move the water. The pump holds water in through the inlet and push it out through the outlet. Do you guys know that the impeller is always immersed in water? When the impeller is made to rotate, it makes the fluid surrounding it also rotate. So, this imparts centrifugal force to the water particles and the water moves readily out. Since rotational mechanical energy is transferred to the fluid, at discharge side of the impeller, both pressure and kinetic energy water will rise. At the suction side, water is getting displaced, so a negative pressure will be induced at I. Such a low pressure helps in sucking fresh water stream into the system again, and this process continues. Do you know that the impeller is fitted inside a casing? So, the water moving out will be collected inside it and will move in the same direction rotation of the impeller to the discharge nozzle. So here, you can note one specialty of casing. It has got the increasing area along the flow direction. Such increasing area will help in accommodating newly added water stream and will also help in reducing the exit flow velocity. Reduction in flow velocity will result in increased static pressure, which is required to overcome resistance of a pumping system. So that's all from me. Next, I will pass to the next presenter to explain more further about this topic.
Now, I will continue with the application of centrifugal pump. I will present two applications which is in food industry and agriculture industry. In food industry, centrifugal pump used as food processing plants. Food processing plants were functioned by transferring liquids from one tank to another, recirculating liquids during processing, cooling liquids during processing, and transporting liquids to and from storage tanks. In addition, this centrifugal pump had simple designs, reliability, and ability to pump large volumes of liquid at high pressures. Centrifugal pump also can be easily customized to meet the specific needs of any food processing application.
Now, I will show you the example of food processing plants that produce canned mandarin products. We can see that the chosen mandarin will transfer through the centrifugal pump to the step grading and peeling the skin mandarin. It makes customers can ready to eat the canned product. After that, the centrifugal pump is running through water to wash the mandarin. We want to prevent an impurities in the product. At the same time, the workers will remove the bad part of the mandarin. Then the mandarins are inserted into can and transferred to the next step for seal the can by centrifugal pump. It makes product not contaminate with microorganisms that produce toxic in the food. Next, the product will arrange in a storage place. Lastly, the product will affix with brand labels and nutritional information and ready to distribute to store for sale.
Next, application of centrifugal pump in agriculture industry, which is irrigation systems. Irrigation system transferring water from reservoirs or lakes to fields and powering farm equipment such as tractors and combine. It also can handle various liquids including water, chemicals, and even sludge and sewage. Irrigation system function by move water from lower elevation to higher ones. It uses centrifugal force to create a water lifting action, which helps move the water up and out of the irrigation systems. Lastly, crops will receive the proper amount of water even during periods of drought or other dry conditions.
This is an example how centrifugal pump functional as irrigation system.
So next, let's move on to the advantages and disadvantages of the centrifugal pump. So firstly, no power loss caused by friction and remarkably simple in design and operation. This is because in centrifugal pump does not require any valve and moving parts. The way for this, it made easy to produce with many different materials, so the outcome become very smoothly and consistently. The second one is capable of pumping hazardous and sensitive fluids. And the third one is no heat transfer issue. This is because the space of the pump between the motor and the chamber sufficiently wide. Next, disadvantages of the centrifugal pump is cannot handle with a high viscosity fluids. And the second one is sensitive to cavitation. And the third one is costly for high pressure application. To achieve high pressure application, we need add equipment such as booster pump or multi-stage pump to increase the capital and operational expenses.
That's all from us. Thank you.